Hello everyone. Today I am solving this problem sorted distance to a character. Now this is a lead code problem and it is an easy problem, but still I am solving it because it's a standard problem, and the way this problem is solved, it is something which is used to solve many questions. So the problem statement says that we are given a string s whose length is less than 10 raised to the power 4 less than or equal to, and we are given another character c which can be any alphabetical character, that is from small a to small z, and it also goes for s, that is it also has lowercase English letters. The problem is very simple, that we are given this character c and we are required to find the distance of every other character from this particular character. For example, suppose that c is equal to E, that is character E or alphabet E. In that case, how far is this L from E? Well, 1, 2 and 3, that is 3 distance away. So we need to return an array which says that this is 3 characters away from E. Similarly, this is 2 characters away, this is 1 character away, this is 0 characters away, and so on. Now if we look at this C, then it is 2 character away from this E, and 1, 2, 3, 3 characters away from this E. So answer in this case for this particular alphabet will be 2. Now the one brute force method is definitely to go to any character that is starting from the first character and moving to the right one by one. Suppose at some instant we are at this character, and then we will see how far this character is away from those E's which are on the left. So I'll only have to move one step and I'll encounter an E, and similarly I'll check for the right character, and that one is also E and it is also one character away. So for this L or for this index, answer is 1. Similarly, I'll move sometime at this C, and in that case I'll start moving to the left. I'll see that there is an E which is 2 characters away, so 2 comma and another E which is 3 characters away, 3. So answer in that case for this particular character or for this particular index will be 2. This method has definitely a huge time complexity, that is, well, it is order of n square. The reason is very simple, that we are moving at every character and then we are going to the left to check the first occurrence of character C, and to the right as well to check the first occurrence of character C, and whichever is smaller we'll place that in our array. So that method order of n square time complexity, and as I told you that we have a length which could be this big, and it means that this problem cannot be solved in this time complexity. So there is a better method, and I have a hint for you. The method actually requires using for loops only twice. That is, once you will parse this string and once more you will parse this string. That is, you will parse this string 2 times and you will have your array which has the distance of every character to that particular given character. Okay, so now let us see that solution. The time complexity of that method is going to be order of n. So in this method, the logic is very simple. We'll only see that when the first occurrence of a character occurred to the left. Suppose that C is given as a character E. Now if I ask you when was the first occurrence of E, if we are looking for this one and we are not allowed to look at the right side, then when was the first occurrence of E? Well, it never occurred because this is the first character itself. So we can say that the first occurrence was when we were at infinity. Therefore, for this one, currently we can set infinity. Now, if we move to the right character, we see that O, and we know that if L is infinity away from E, then O is going to be infinity plus 1 character away, and infinity plus 1 is also infinity. Again, we move to the right. Same logic follows, that we check that if O is infinity distance away, then V is infinity plus 1 distance away, which is also infinity, and then we move to the E. Now we can see that E is the character itself, so there's no point in checking what's the distance of this character E with V, and we can simply say that for this character the distance is 0. Again I move to the right, and if E is 0 distance away from E, then it means that L is 0 plus 1, that is, it has a distance of 1 unit. from E, and yes, we can see that it makes sense. Again we move to the right. Again the same logic applies. This is the character that we are looking for itself, and therefore for this character we have 0. For this character or for this index we have 0. Again we move to the right. This time we have 1. Again we move to the right. Now this has 1, that is E has occurred at a distance of 1 unit from T on the left. Then from C it will occur as 1 plus 1 distance, which is 2. For O it becomes 3. For D it becomes 4. For E it becomes 0 again. Now this was the first pass, and yes, it is correct that L is infinity distance away from E on the left. Similarly for O and B, and E is 0 characters away, L is 1 character or 1 unit away from E on the left, and so on. Now this time we will also do the same thing, but this time we will check how far the current character is away from the required character if the required character is considered to be in the right direction. That is, for suppose that this was not E, and if this was F and we were looking for character E, in that case we can see this F is actually infinity distance away from the E which is located on the right, because it is nowhere to find. So yes, this is the case pretty much itself, and now you will see how we will get to our answer. So this is the first character currently we are at, which is E, and we can see simply that it is at 0 distance away from itself, and yes, we can consider it to be on the right, and therefore this becomes equal to 0. Now we are at this character D, and from right we can see that the right character is 0 distance away from E. So this character from the right is going to be 0 plus 1, that is 1 distance away from E. And what is better, 4 or 1? What is the minimum? Definitely 1 is minimum, so the answer will itself become equal to 1. Again we move to the left, and this time also we can see that O is 1, that is this one, plus 1, that is 2 distance away or 2 unit distance away from the required character E, and therefore I'll write 2 here, and the minimum of 3 and 2 is 2, therefore our answer will be 2. Again I move to the left, and this time I see a C, and from the right it is 2 plus 1, that is 3 characters or 3 unit distance away. On the left we can see that it is 2 character distance away, therefore in our answer we'll pick this 2. And again I'll move to the left. Again I see that T is 4 distance away from the right and 1 distance away from the left, therefore answer will be 1 for this index. Again we move to the left and we are at this E, so 0 because it is the required character itself. Again 0 because it is the required character itself, and this time we are at L, and it is 1 character distance away from the right E because 0 plus 1 is 1, and from left also it is 1 character distance away, so minimum of 1 and 1 is 1, so in the answer we will take 1. Again I'll move to the left. Again this is the character itself, so 0. Again we move to the left, and this time this E is 0 distance away from E, and therefore this V will be 0 plus 1, that is 1 unit distance away from the required character, which is E. Again I'll move to the left, and this time also this character will be 1 plus 1, that is 1 plus 1 character away, that is at a distance of 2 units from the required character E. Again I'll move left, and this character is 3 distance away or 3 unit distance away from the E which is on the right side, so 3. Now as I told you that we will take answers to be the minimum of these two, and therefore the answer array will be, so this was the way to actually solve this question. And as I told you already that we are only using 2 for loops to solve this. Once we are moving to the right, checking how much distance away the required character is from the current index, and what it will be, the distance of left character plus 1, because as we move to the right, suppose that this is the required object and something is on its right at a distance of 1 unit, that is here, then its distance from this will be definitely 1. And if we move 1 unit to the right, now the distance of this object will be the distance of this from the required object plus 1, that will be 2. So this is how we did the same thing when we check for the presence of the required character on the right side, and in that case we move to the left. So this is how you can solve this question. And yes, time complexity of order of n, and now it's time to code the solution. So I'll start by taking a vector of integers, which is the array or the vector that is required, and let us call this thing answer. Now how many characters, or what will be the size of this array? It will be equal to the size of the given string. So let us say that we have an integer n which is equal to size of the string, and the size of this will be equal to n as well. Initially let us assume that the distance or the values that will be are int max. It could be -1, it could be anything. Next, what I am going to do, loop in the array, and yes, before this I also need the previous distance, which will be initially equal to something around infinity, but infinity plus 1 is going to overflow and come back to negative distance in C++, and that is if I take int max. But I know that the maximum possible size of the given string is 10 raised to the power 4, therefore it is actually safe to take this previous equals to n plus 1. And now for int I is equals to 0, I is less than n, I plus plus, that is I am passing the vector or the string actually, and if s of I, that is if current character is equal to the required character which is C, in that case previous distance is equal to 0, otherwise previous distance actually increases by 1, like this, and answer of I is equals to previous. And now I am going to do the same thing but in another direction, that is from right to left. So int I this time is going to be equal to n minus 1, I will be greater than -1 and I minus minus. And again let us say that previous is equal to n plus 1, and if s of I is equal to the required character, then previous is 0, otherwise previous is increased by 1, and this time answer of I will be equal to minimum of previous comma whatever is there already, that is answer of I. Finally I'll return the whole vector answer, and yes, that's it. So now it's time to run this code, accept it, and submit, accept it. So that's how you can solve this problem, and yes, that's it. So I'll see you in the next video. Thank you.